everybody, welcome back to the lab. Up to this point in this course, we've been talking primarily about internal energies. These are energies that are internal to a substance. They don't depend on things like the position of the substance or its speed. But there are energy systems that do depend on these things. They're called mechanical energies. One of the nice things about mechanical energies is that we can analyze them using some of the same techniques we've used for internal energies, particularly the energy interaction diagrams. Just as internal energy systems can exchange their energy, mechanical energy systems can exchange their energy as well. Let's do an example to see how that works. We'll start with this golf ball. Now, what's going to happen if I let go of this golf ball? As we all know, it's going to fall to the ground. But why is that? You may say, well, gravity is pulling it, and that's true, but we can think of it in terms of mechanical energies. Let's drop this and watch this exchange of mechanical energies at work. By holding the ball above the floor, we're giving it gravitational potential energy. This is energy that an object has whenever it's near a large gravitating object. In this case, the large gravitating object is the Earth. When we release the golf ball, that gravitational potential energy is converted into kinetic energy, just energy that the ball has because it's in motion. Let's watch that again in slow motion. Notice that the ball increases its speed as it approaches the ground. This is because as it falls, its gravitational potential energy is decreasing, meaning that energy must go somewhere else. In this case, that energy is being turned into kinetic energy, just energy that the ball has due to its speed. An increase in kinetic energy translates to an increase in the speed of the golf ball. Let's do a second example. I have here a coffee filter. A coffee filter is very different from a golf ball in some meaningful ways. First off, it's significantly lighter than the golf ball. Secondly, it has a much larger surface area. What little mass it does have is spread out over a much larger space. What do you think will happen when we drop this coffee filter? It is going to fall just like the golf ball, but there are going to be some key differences in how it falls. Let's watch this and see what happens. In particular, I want you to look at how the coffee filter behaves about 1 second after it has started falling. Unlike the golf ball, which sped up all the way through its fall, the coffee filter does not seem to speed up meaningfully after the first second or so. Let's think briefly about what this means from an energy interaction perspective. The gravitational potential energy of the coffee filter is still decreasing because it's falling downwards. However, its kinetic energy after the first second or so is not increasing. So the energy that is leaving the gravitational potential energy system must be going somewhere else. In your groups, you're going to discuss where this energy is going. I'll give you a hint. It has to do with the fact that the coffee filter is far more spread out than the golf ball.